Hey guys, welcome back. Houston Math Prep here. In this video, we're going to look at the connection between inequalities and interval notation. So in this video, we're going to look at, first, what is interval notation? What am I even talking about when I say interval notation? So interval notation is a way of expressing a range of values. So let's take a look here at our first inequality statement and translate that to an inequality statement. So this first one reads, x is less than a. That means there are infinitely many values of x that we can use here. Every value of x that is less than a is a part of our solution. So we learned in the last video that we can graph that on a number line by putting an open dot at a and shading our number line down to the left of A. Now, if we think about the endpoints of our number line, or the far, far left and far, far right, since they aren't actually endpoints, on the far, far left, we think about going toward negative infinity, which negative infinity just means a very, very, very small negative, or a very large negative number, let's say it that way. And on the far, far right, we have the concept of positive infinity, which is a very, very large positive number of some sort. So we can use our graph here that we've created on our number line to write an interval notation for this inequality statement. So what we can do is we can go from left to right and say, all right, well, on the left side of my graph here, I have a negative infinity. I'm going to connect my two endpoints with a comma. On the right endpoint of my solution graph, I have A. Now we want to look at what kind of closures that we want. There are two types of closures that can be used. You can use parentheses, either left or right or both, which means not included. That means that the endpoint closed by a parenthesis is not included in your solution. Or you can use brackets. Brackets mean that that endpoint is included. So because negative infinity is not a value, it is not a number, it is more of an idea, we can never include negative infinity. So that one is going to get enclosed by a parenthesis. Here on our A, because we have this open circle and we do not have an equal to symbol, A is also not included, so we would close the A side also with a parenthesis. All right, so using that knowledge, let's fill in our next couple. So if we have x is less than or equal to A, we know that the graph of that is going to look very similar to x is less than A, where we are shaded to the left or below A. But a big difference here is that A is now included, so we're going to put a solid dot at A. So now looking at our quote endpoints here, we're going from negative infinity up to A. Again, negative infinity is an idea. We can't ever include that, so that's going to be closed with a parenthesis. But A now is included because we have equal to A and we have a solid dot. So that side of my inequality is going to get closed with a bracket. Jumping now over to x is greater than A. When we shade greater than, we shade above or to the right. So open dot since we have no equal to symbol. And now we're looking at infinity as our upper bound. When we write down our bounds for our inequality, we need to go from left to right. So on the left-hand side of my solution graph, I have A. And on the right-hand side, I have positive infinity. A has an open circle and no equal to symbol here, so we're going to close that with a parenthesis. And the same way that we can't include negative infinity because it is an idea, we cannot include positive infinity. So we're going to close that one with a parenthesis. And last one, x is greater than or equal to A. That's going to look very similar. We're going to shade above or to the right of A. We're going to include a in our solution by making a solid dot because of the equal to symbol. And we've still got infinity on the right-hand side. So, reading left to right on my graph, I have a up to positive infinity. This time a is included, so I'm going to close that side with a bracket. Positive infinity is an idea, not a number, so we cannot include it. I'm going to close that side with a parenthesis. Okay, let's look at two concrete examples of this. Let's express these two inequalities using interval notation. So our first one here, x is greater than -4. Now you might find it helpful to draw yourself a little number line and graph that. So if I pop -4 on my number line, remembering that negative infinity is always to the left, positive infinity is always to the right. So if x is greater than -4, I'm going to shade above -4. There's no equal to sign, so I'm going to have an open dot here. That tells me that my interval notation reading left to right is going to have a -4 and a positive infinity. Since -4 is not included, I'm going to close with a parenthesis. Infinity always gets a parenthesis. So the interval notation that matches the statement x is greater than -4 is -4 to infinity, both pieces having a parenthesis. All right, last one. X is less than or equal to 1/3. Once again, you may find it helpful to draw yourself a number line. Here's 1/3. X is less than. Remember, this pointy part points to the small part. So here's negative infinity on the left. Here's positive infinity. If x is less than 1/3, we shade below or to the left. Because we have that equal to symbol, we're going to close with a close dot here. Filled in dot on our 1/3. All right, now translating that to interval notation, looking at my two endpoints of my shaded region from left to right, that is negative infinity, then 1/3. Connect those guys with a comma. Negative infinity is an idea, it cannot be included, so that's a parenthesis. But 1/3 has a solid dot because of this or equal to sign, so bracket. So the interval notation that matches the statement x is less than or equal to 1/3 is negative infinity with parenthesis up to 1/3 with a bracket. All right, guys, that does it for this video. We'll catch you in the next one.